All right, so in this problem, we're going to go ahead and we're going to graph this function, and then we're also going to then describe the type of transformation that was done to it from the original cosine function. So you essentially want to start off by interpreting this function and its four values that change it. So like there's four ways it can be transformed for the most part. So we have y equals a times the cosine of b times x minus h plus k. And so let me put this part actually in parentheses so that can stand out better. And let's address what those values are. So then the value of a is -3. The value of b is 2. The value of h is going to be pi over 2. And then the value of k will be -2. Okay, so this a value, that affects the vertical stretch of the function or the amplitude. So this is going to basically stretch the function by a factor of 3, and then the negative symbol flips it over vertically. So we could basically say vertical stretch by a factor of 3 followed by a vertical reflection. So let's write that vertical stretch. Of factor equal to 3 and a vertical reflection. Right, the b now. The b is going to be a big thing because that's going to be the period. So the b is going to affect how it's stretched out or compressed or shrunk. You can think horizontally. So the period is equal to 2 pi over the absolute value of b over the absolute value of 2. Since 2 is already positive, we don't really have to worry about that. So the period is just 2 pi divided by 2 or just pi. So the period originally of cosine is 2 pi. So it gets shrunken down to just pi. So what it does is that it basically shrinks it. So you can say it compresses it or shrinks it, but it shrinks it horizontally. So horizontal shrink by a factor equal to 1/2. The factor is 1 over b when we're talking about the horizontal, stretch or shrink. Right now, let's look at h. H is simply going to shift the graph or translate it horizontally. So it translates it to the right if it's positive or to the left if it's negative. So since it's positive, this is a horizontal translation, pi over 2 units to the right. Horizontal. That's not how you spell translation. You got an S there. Not a problem. Horizontal translation. Pi over 2 units to the right. And this last value, k -2, it's also a translation, but in the vertical direction. And so since it's negative, it's going to be a vertical translation 2 units down. Vertical translation 2 units down. Okay, so those are all of our transformations. So now let's just calculate some of the points, and I'm gonna go through it like by plugging them in and calculating one by one numerically, just so that you can follow along and make sure that you know how this inputs work, because sometimes when you see a cosine function with a bunch of parentheses and subtraction, you may get a little confused with the algebra. So the key here is to have the period be divided into 5 points that you're going to evaluate for. So I like to always just go like and start at 0 and then end at pi, or end at the period length. But we have to find 5 total x values. So I'm going to go like this. So 1, 2, let me just go x1, x2, x3, x4, and x5. So x1 is 0, x5 is pi. So we have 3 points divided evenly along that interval. So x3 is in the middle. So x3 will just be pi over 2, or 1/2 pi. And x2 will be in the middle of 0 and pi over 2. And that's just going to be 1/4 pi, or pi over 4. And x4 will just be halfway between pi over 2 and pi, which will be 3/4 pi. So now we just evaluate the function for these 5 x values. All right, so let's do that. Let's go ahead and plug those in. So we go ahead, plugging 0 into the function. So y will be equal to -3 times the cosine of 2 times 0 minus pi over 2 minus 2. So this will be -3 times the cosine of 2 times 0 minus pi, or just negative pi. So let's see if you see negative pi over 2 times 2. So this will be 2 pi over 2. So the cosine of 2 pi over 2 minus 2 is equal to, and it's 2 pi over 2 is just pi. So all we have is -3 times the cosine of pi minus 2. So -3 times the cosine of pi. The cosine of pi is -1 because it's on the left side of the unit circle. So -3 times -1 minus 2. So -3 times -1 is 3, minus 2 is just 1. So your first value will be at 1. All right, next, now let's look at x2. Let me switch colors so it's easy to distinguish. So y will then be equal to -3. Oh, we're still fly here. -3 times the cosine of 2 times pi over 4 minus pi over 2 minus 2 is equal to -3 times the cosine of pi over 4 minus pi over 2 is negative pi over 4. So this becomes negative pi over 4. And 2 times negative pi over 4 is just negative 2 pi over 4. Minus 2. And this is just negative 1/2 pi, or negative pi over 2. So what we're doing is -3 times the cosine of negative pi over 2. So the cosine of negative pi over 2 is just going to be 0 because it's going to be at the bottom of the unit circle. So -3 times 0 minus 2, or 0 minus 2, and we'll get -2 for our second y value. All right, next we got x equals pi over 2. Y will be -3 times the cosine of 2 times pi over 2 minus pi over 2 minus 2. This will be equal to -3 times the cosine. Pi over 2 minus pi over 2, that just becomes 0. So if we have 2 times 0 in here, we're just looking at the cosine of 0. Then minus 2. So this is going to be -3 times the cosine of 0. That's the start of the unit circle, which is going to be then 1. So this will be -3 times 1 minus 2. -3 minus 2, and that'll be -5. All right, 3 down, 2 more to go. Now we just got 3 pi over 4. So we plug in 3 pi over 4 into x. So we'll get -3 times the cosine of 2 times 3 pi over 4, 3/4 pi, minus pi over 2 minus 2. Zoom out a little bit. And then we get -3 times the cosine of 2 pi. So here we have 3 pi over 3/4 pi minus 1/2 pi. And then that'll just be, this will end up being just 1/4 pi, or pi over 4. So 3/4 minus 1/2 is 1/4. So then we have 2 times 1/4 in there. So then we essentially just have 2/4 pi, or 2 pi over 4 inside, minus 2. So we have -3 times the cosine of 2 pi over 4. 2 pi over 4 is just 1/2 pi. So this is the same as just pi over 2. So the cosine of pi over 2 is the top of the unit circle, which will be 0. So -3 times 0 minus 2. So 0 minus 2. And we will get -2. All right, one more. So here's something that if you've been doing this for at least a couple, lessons or practice problems, what should happen and what will happen, because this is math, is since this is one full cycle, then when we evaluate the function for pi, it's just going to come back to the original value. And so we started at 1. See how we're cycling back? We started at 1, went to -2, went to -5, went to -2, and we're going to come back to 1. So when x is pi, well, y will be, well, let me write this formally, h of pi up here. H of pi, or when you plug in pi into this whole thing, this whole function, you're going to get 1 again. So I'm going to save you some work, because I'm actually running out of room here. It's going to go back to 1, guaranteed. So now let's just go ahead, let's graph these on this graph here. So let's make sure we have enough room to go down to -pi. And scoot the graph maybe up here. And breaking it up at 4, so we get 0, pi over 4, pi over 2, 3/4 pi, then pi. And then keep it going. So we got 5/4 pi, 6/4 pi, or 1.5 pi, 7/4 pi, 8/4 pi, or just 2 pi. And other way around, negative pi over 4, negative pi over 2, negative 3/4 pi. And let's go ahead, let's plot these. So at 0, 1, all right, let's scale this by like this. 1, 2, negative 1, negative 2, negative 3, negative 4, negative 5. So we have one at 0, 1 right here. Then pi over 4, negative 2 over here. Pi over 2, negative 5 over here. 3/4 pi, negative 2. And see how we're cycling back? When we go to pi, we're going to be back at 1. And that's because the midline is going to be right here, the line y equals negative 2. That lets you see the symmetry of it rounded. Y equals negative 2. And then we could easily tell what the pattern is because we're going to go then back to it. And then we're going to go all the way back. We're going to go down to negative 5, then back up, then back over here, then other way. All right, now let's connect them. Yes, we're going to go. Oh my god, that was messed up there. I'm losing my. There's a crease in the table or something. No, I got it. I'm usually a lot better at this. Believe me. I don't know what's going on. I think there's like an earthquake going on or something. Anyways, so here we go. There's your graph. There's your cycle. Looks good. See how it's stretched out? That's what that vertical stretch. It has a amplitude of 3. And the period, it only goes, or the period is half as long. The period goes from 0 to pi. So the period is pi. Normally it's 2 pi, remember? So the period, the length it takes to recycle is half as long as it normally is. That's where that horizontal shrink by factor 1/2 comes into play. But the good thing about this is that if you can graph this, you can graph any other transformation. And this is the hardest one I put in my notes. It has the most work, most calculations. So that's why, I went through all that and broke it down. So if you can, again, you can practice this one and do it correctly, all the other ones are going to feel like a child's play, not an issue. All right, so good luck. Hope that helps.